Hi, Algebra 2 students. My sixth period class requested I make a video to kind of give you some hints for the homework. So I'm just going to kind of record some of my brief thoughts. So I already started to annotate problem number 4, if you can kind of see this. So we have a cashier has 25 total coins consisting of nickels, dimes, and quarters with a value of $4.90. If the number of dimes is one less than twice the number of nickels, how many of each type of coin does she have? Okay, so first step would be to define our variables. I already started to up here. So I said N is going to be the number of nickels, D is the number of dimes, Q is the number of quarters. Okay, then the first sentence actually has embedded in it two different equations. Okay, so within the first sentence, we can kind of set up the first equation is going to be something with relating the variables is going to be equal to 25 total coins. So I'm going to leave you to kind of fill in what goes on the other side of that equal sign. And then a second equation we can set up that will be equal to the total amount of money, which will be 4.90. So remember, like in this expression, you're going to have to use the 0.05, the 0.1, and the 0.25 to represent the amount of money you get per quarter, per nickel, per dime. Okay. Now, the last equation has to do with this second sentence, which is if the number of dimes is one less than twice the number of quarters. Okay. So the way I'm going to set that up is I'm going to say the number of dimes is equal to one less than means take away 1 from what? From twice the nickels. So that's going to be 2 times n. So I have d equals 2n minus 1. And then I'm going to let you guys try to set up those other two equations, which should be similar to a problem on the front of the worksheet. Okay, so now we're going to look at the next problem, which is about investments. So we have Jovita divides $17,000 into 3 investments. So we have a savings account, which pays $6 in interest annually. So she's making 6% interest every year. A bond where it's paying 9% interest, and then a money market fund, which is similar to a mutual fund, paying 11% interest per year. And then it says that the annual interest from all 3 accounts is the $1,540. Okay? So first of all, there's one more thing. So then it says, and she has 3 times as much invested in the bond as in the savings account. Okay, so first of all, our variables are going to be the savings account, the bond, and the money market fund. So I'll say like S is like the money in the savings. B is the money in bonds. And then M is the money in the money market fund. Okay, so now one of my equations I'm going to set up is going to be equal to the total amount of money. I don't need to write the $sign, so it's just going to be equal to 17,000. Another one of my equations is going to be equal to that total interest that is earned. So that would be the 1540. And for that one, I'm going to have to kind of use on the other side of that equal sign the 9%, 11%, and 6% and relate them to my variables, right? Because I'm going to take 6% of the money in the savings account, 9% of the money in the bank bond, and then 11% of the money in the money market account. The last equation has to do with this. She has 3 times as much invested in the bond as in the savings account. So we're relating the amount in the savings account to the amount in the bond. So if there's 3 times as much in the bond, that means the bond is equal to 3 times the savings account. Okay, and I'll leave you to set up those other 2 equations. So moving on, this next problem, number 6, is similar to the number 8 from the front. The sum of the digits of a 3-digit number is 9. So we have sum is 9. The tens digit is 3 times the hundredths digit. And if the digits are reversed in order, the new number is 99 less than the original number. So this is really going to be similar to the problem we spent time in class on today. So the idea is we can say X, Y, and Z are the digits in each place. So this would be like hundreds digit, tens digit, and ones digit. And I'm going to leave the first two equations for you to set up. So the sum is equal to 9. The tens digit is 3 times the hundreds digit. I'll leave you those two to set up. But now let's look at the last equation is if the digits are reversed in order, the new number is 99 less than the original number. So remember, like, the original number we can write as 100 times x plus 10 times y plus 1 times z. And if I added up each of those things, I would get the total original number, right? But now it's saying that we reverse the order of the digits. So instead of being a number x, y, z, it's going to be a number z, y, x, which means we have the 100 times z and a 1 times x. I'm going to switch those two variables in the expression. And that's going to be equal to 99 less than the original. So if this is my original number, then I want to subtract 99 from it and set it equal to the expression where I reverse the digits. So that would be the 100z plus 10y plus 1 times x. Okay, so that would be one of your equations. And there are 2 more equations for you to write. Okay, so now let's look at this last problem here. Let's find some space. Okay, this problem seems really like a big old mess. There's a lot of information in here to kind of parse through. So it says we have experiments have shown that cars, trucks, and buses emit different amounts of air pollutants. In one such experiment, a truck emitted 1.5 pounds of carbon dioxide per passenger mile, 2 grams of nitrogen oxide per passenger mile. Okay, so we know we have 1 pounds of carbon dioxide and 2 grams of nitrogen oxide. It might be useful to kind of organize this information in some sort of table because there is a lot of it. So I'm actually going to do that right here. So we'd have for the truck and for CO2. And then we also have an amount of nitrogen oxide, right? So I know that for CO2, the truck is 1.5. And for nitrogen oxide, it's 2 grams. And this is pounds. And then I could do the same thing for my other variables, which would be the next sentence talks about cars, so I'll do cars next. So it says a car emitted 1.1 pounds of CO2 and 1.5 grams of nitrogen oxide. And then we have the bus. The bus has 0.4 pounds of CO2 and 1.8 grams of nitrogen oxide. Okay, now the last sentence says that there's a total of 85 miles driven and there's a total amount of CO2 and a total amount of nitrogen oxide, right? So I'm going to kind of make a total column. So for CO2, the total is 73.5, and for nitrogen, the total is 149.5. And when we think about how we're going to define the variables, well, if you look at what the question is asking you to find, it's asking you to find the miles driven by each variable. So what that means is that I'm going to have C represent the number of miles that the car drives. I'll have T represent the number, I'm just going to kind of use those little quotation marks to mean like I'm pulling down the previous thing, so by a truck. And then B will be the number of miles driven by the bus. Okay? So the idea would be like the number of miles that the car drives times like the total amount of CO2 per mile would give, so like this is like a per mile amount. So then you'd have to multiply it by the number of miles to get the total amount of CO2 used, right? So if I was to model, the first equation I would write would be that I would have 1.5 pounds of CO2 per mile for the truck. So I'm going to say times T plus 1.1 times the number of miles that the car drives plus 0.4 times the number of miles that the bus drives should equal a total amount of CO2, 73.5. And you can do the same thing going across here to set up another equation for the nitrogen oxide. And then the last equation, I'm using the fact that there's a total amount of miles driven. So think about like what would need to go on the other side of this equation if it equals the total amount of miles. Okay, so I'm going to leave those last two equations for you to finish. I hope this helped if you are watching, and I can also answer more questions in class tomorrow.